Actually, I'll share a different way.
Okay. All right. Let's see. Well, for people who are joining this live stream, we are talking about the foreign function interface. And I know nothing, so Christopher is going to explain this.
Sure. Well, basically, this is a packlet that uses the compiler stuff like library function declaration to connect to a library called libffi, which lets you connect to other libraries. So the main difference between, well, so maybe two points. So the first thing is it's different from library link, because in library link, the libraries you link to, they have to expose functions that are in a very particular format that's specific to connecting to, a Wolfram language kernel. And so, you can't just connect to some random library in the wild. You have to compile something in between, which you have to generally write in C, C++, or something like it. The other distinction is this is a bit different from the compiler methods for connecting to libraries, because this is all at runtime. So with those, you have to basically compile some library that links between the external library and the kernel. Here, there's no intermediate, no compilation has to happen in order to call a foreign function.
Okay, so what's an example of a thing that exposes a foreign function, an interface that is capable of being connected to like this?
Well, an obvious example. I don't have a. Maybe I think I have a guide page that will show this. One obvious example would be like, I have some like OpenSSL examples or like SQLite examples,
okay,
where you can see.
Let me just understand. I mean, OpenSSL is delivered as a library. Is that right? What kind of what kind of file is it?
It's basically it's two .sos or .uilibs or whatever. I think it's different on Windows, but ultimately it's something like that.
Okay, but do those libraries, do those files have a discovery interface of some kind that libffi can hook into, or how does it work?
Not really. They don't really. There isn't really a discovery interface. Instead, it's just if you DL open a library based on its path, and then you call DLSim, and you give it the name of a function, and it will give you a function pointer.
Oh my gosh!
So that's essentially what this is doing.
Okay, so this is okay. And then how does it know what the calling structure of that function is, or it doesn't? You have to tell it that.
You have to tell it. So you have to tell it this is the type signature of my function, and then this is the magic of libffi is knowing, given this is the type and here's a function pointer, how do I actually call this function?
I see. So hold on. So I mean, these are non-stripped binaries, so they still have the names of the symbols in them. Is that right, or am I confused?
Yeah, I mean, they still have the names.
Well, these are dynamic libraries, not .lib files. Shared libraries, dynamically loaded libraries.
So just so I understand,
to be clear, even stripped dynamic libraries still have the symbol names, because that's fundamental to being able to use them.
Yeah,
it's debug information that's typically stripped.
Okay, right. So I mean, and I see. So just so I understand the technology a bit, because I need to be modernized here. In an actual binary, an executable, there is only one entry point. It's just main or whatever. And so, for example, if you strip the binary, then there are no readable string symbol names at all there. Is that correct? Just binary. Or is that not known to you guys?
I don't really know how that works. I mean, I know obviously if you do run strings or whatever, names or whatever on a stripped binary like the kernel, you do still see some strings, but I think it's just string literals and stuff.
Right, you don't see, but before you strip the binary, the loader still has actual names of strings that correspond to this. But so the point you're making is a dynamic library. If you don't have those names, you have no idea, what the entry point, what the address to go to execute anything is. Therefore, those things are still there in a dynamic library. Okay.
Right, and you see this if you do, library function load. Library function load takes a library and then a function name, right?
Mhm.
and then the type signature.
Okay. So there's a mechanism for, okay, so then, okay, so what's happening here is you've got the library, you've got a name of function, and I mean, does it matter what kind of how this library was created, what language it came from, things like that, I'm still a
Well,
bit
so I mean, basically, all
don't different languages have different ways of putting function arguments on the stack?
It has to have C linkage, right? The C linkage, right?
yeah,
Christopher.
CABI compatible, yes. Which basically all, as far as I know, I mean, maybe Fortran or COBOL is different. As far as I know, any language that really claims to be able to produce a dynamic library produces a dynamic library that it conforms to the CABI.
Yeah.
Okay, all right. This is
every DLSim on your whole system will use the same format.
Okay, I think you're right. The Fortran works differently, or at least used to. Maybe it's maybe made compatible.
Right, but no one is going to be like, here's a .dylib from Fortran, and they're not going to. If they do that, they're going to make it very clear that they're giving you something very strange.
Yeah,
I hope.
Well, and I'm sure this C interface layer has probably been built for Fortran by now. Okay, I think I understand what the theory is here. Okay, now what happens? So,
right. So now what happens is okay. Here, for instance, I have a. This is just a demo library that it just comes in the product, and it includes a function called add1 that takes an int and returns an int. So what I'm going to do is I can say create foreign function, and given that this library's already been loaded and it's sort of it's in the system, I can run this and it'll create this sort of foreign function object. And I can call it by saying call foreign function. I can give it the object and I can give it a list of its arguments, and it will give me the output.
And so why isn't that, a thing that's called foreign function of blah, blah, blah with subvalue 12?
You mean this? Why don't I write this?
Yes.
Well,
or a decorator of add1. I mean, it could be a blob. In other words, you could have a thing called foreign function, and then it's
why isn't it that?
Yes.
It could be. Yeah, it could be. I mean, so the reason that I haven't done that yet is sort of for silly performance reasons. That basically, when I make it a sub value, so this call to call foreign function is has very little overhead. I think it's like on the order of 10 to the minus 7 seconds. The overhead of running a single sub value is 10 to the minus 6 seconds. So it's sort of for the purposes of minimizing overhead, which is one of the nice things, it sort of destroys it to use a sub value. But I understand that. I mean, ultimately, there'll have to be a version of this that exposes a sub value, because people often don't care about that level of
right. Well, I mean, maybe
overhead.
there's a way of optimizing the sub value, and certainly if you compile the thing, the compiler should immediately, I mean, part of what you're saying there is there might be a level of quotes compilation that's just a rewriting, a transformation from the sub value to that call foreign function thing. That, I mean, the best thing to do will be to fix the overhead with the sub value.
Maybe, but that might be a deeply ingrained thing in the kernel.
It might be, but I think I would predict. Okay, but that's okay, right? No, but that's a defined sub value. What if it's a C code sub value? What if it's I forget what it's called. Instead
of
the
S value or whatever, S function.
Yeah,
I'm not sure. Actually,
I bet that will be fast.
Yeah, this isn't also so bad. I mean, it's an order of 2 slower, but that's not. It's still
that's
still
top level code.
Right.
So I think this is going to be a no problem thing.
Yeah. Okay. Fine.
And I think it's nice because we've got external function. What's the relationship, the explainable relationship between foreign function and external function?
Well, I think that's one thing that, I mean, if we're talking about including in the system, that's, I think, an important topic, because I think arguably this should just go into external function, but maybe Todd has a different.
Yeah, well, I was thinking about that. I'm not exactly sure if external function has this notion of a session. It's designed for external evaluate where you have, a long-lived set. It would probably work fine to just have this be an external function return from create foreign function. I haven't there might be some weird impedance mismatch between
I
external
think
function and
it's
this.
not a good idea. I think that this thing, you see, I think external function, well, I was going to say is really a creature of interpreted languages, but that's not really right. And also,
Right.
you know,
I would have imagined that the reason why we have external function, not just external evaluate, is so that we can do stuff like connect to compiled languages.
yeah, well, right. But I mean, look at that external function, Python abs. I mean, that's a very weird thing because it's based on a session as opposed to being, you know, it is a function that comes from an external session of some kind.
I mean, would it make sense? I mean, if we just defined some kind of special session that is the current kernel state, you know, the
Yeah.
dynamically
That makes
loadable, it's different, but it'd be distinct.
Well, no, the first usage is just sys, not session, right? So, I mean, that's what this is doing. I mean, this is secretly creating a Python session, but I think it's not inconsistent with the first usage to do something like this, right? The system is C or something like it, and this is the function.
Right. I might suggest just CABI since, I mean, as was talked about, lots of languages support the CABI, but
The cabby.
yeah. I think we'd want the name to suggest that it's like the current, you know, it's in process, whereas that Python thing is obviously a whole different process. It's the current, you know, memory space of the current process. Some name that evokes that. Yeah.
Right.
That seems more relevant. I mean, the external function of dynamic library, but I kind of like the foreign function brand. I mean,
plus there's a bunch of other support functions, and maybe they all start with FFI or something. We have to brand all these things anyways.
well, let's take a look some
Right.
more at the design. But I strongly think that the way this should be called in the end is it should just look like, you know, it could even have a nice decorated blob.
Right. I totally agree that this really needs a foreign function object as the return, or a external function, some sort of blob that then you can just call as a function.
But so let's
Right.
just understand how do you get to this? So you say load a library load of something, and then
Right.
now so that thing of create foreign function, that takes some effort for it to do that. Is that correct? That's not just a symbolic wrapper.
It's not just it takes it not very much effort, but I mean, basically it's calling DLSim, which is the function for given you have a loaded dynamic library or an open dynamic library, find me the function pointer for this symbol. And it's doing a little bit of allocation, but that's about it.
Okay. Talking of allocation, what happens when is there a bunch of memory management footwork that has to be done around this stuff?
Yes, not around this, but around, there are basically a whole bunch of functions that are the main kind of arguably, is most of the stuff in this packlet, which are about producing arguments that you can give to this thing and then interpreting things that you get back. And those have to do lots of memory management dancing.
Okay, so hold on. So but the basic workflow here is, if I see some random library, let's take GEOS as an example.
Mm-hmm.
I mean, could you just say library load of, I mean, that's a file name that you're putting in the library load function, right?
Yeah, well, actually, GEOS might be, if I do, okay, I can cheat a little bit because I know that GEOS, if I do this and I say, or to GEOS of, this might load slightly slowly because of oh no, it's fine. Okay, so now I know GEOS is loaded. So if I do, GEOS, I don't know, GEOS intersection, and then I said, this takes 2 pointers and returns a pointer, there it is. That's a callable thing now. I mean, it's not one that I can call right here because making these pointers requires calling other GEOS functions, and I don't remember all the names of them, but
yeah,
but that's basically what you would do.
So is it the case that, given that you loaded a library, can you do discovery at the level of even knowing what the symbols are in that library? How do we do that? There must be a way to extract information on what the symbols are in a library.
So I don't really know too much about it. I know there is sort of a metadata field in dynamic libraries where you can put sort of arbitrary information. I'm not sure.
Thing which goes and finds you the function pointer for a function. There must be something that lists all the things for which you can do that.
Right. So two things. The first thing is I don't think it knows the types. You have to tell it the types. DLSim doesn't know the types.
Okay.
The second thing is I'm not entirely sure how that works, and I'm not sure if you really can get a list easily.
Seems like it'd be nice if one could, because that would be to me, I mean, what does library load return?
Library load returns a path, I think, that it loaded from.
Okay, but the alternative would be to return a blob that is a symbolic thing representing a library.
Perhaps.
I mean, one problem is that, I mean, for example, so the way debuggers work, as I understand it, is that if you're debugging an executable, it has debug information, and there's a format, dwarf, which is seems to be kind of a semi-cross-platform standard for this. The debugger reads the data in that format, and that's how it can do things like, for example, if you say print out this particular stack frame, and it shows you all the local variables at that frame in the stack, and it can even format them if it has type information. So if one's a string and one's an integer or whatever, it can use the dwarf debug information to know that and format it. So I think there is a world in which it's in principle possible to derive this from a library, but it's only possible if that library has debug information, which is not obviously generally consumed in kind of a released.
Okay, so
sorry.
Yeah, right. But so I mean, your point is, if you compiled the library, let's say you were trying to write this in the most stupid possible way. You don't know. You assume you can't read the code of the library very well. Well, okay, so we have to make some assumptions. If you were able to recompile the library in debug mode and read its dwarf file or something, then perhaps you could get some discovery that way. That may be fictional. That may not be a situation that you're ever in, that you can't read the code, but yet you can recompile.
I think it's easier to read the code than to recompile often. And also there's documentation. Like if you're really trying, if you're being.
To use this sort of thing, you need to, it's not that useful to have a discovery mechanism that simply lists the symbols from the dynamic library, because you can't call them unless you have full documentation. And so you basically have to go to the docs or some example code or something that uses these functions in C or some other language. And then
I think you have to go modern. You have to go ask your favorite chatbot to read the documentation and generate the
write a
generate fake examples that don't actually work.
Foreign function call for the certain function from a certain library and spit it back.
Might work.
Well, I mean, so this is I think maybe a kind of phase 2. There are a couple different phase 2s that could happen, but one phase 2 would be to basically try and read header files to automatically create foreign function. And that seems like that's usually the way that people try and automatically do discovery for libraries like this. It's also a method that, based on everything I've read, is like extremely fraught, and it basically
that's been tried
doesn't really work.
At least twice by various people during my tenure at Wolfram, and it's never been successful to try to parse header files. There's always some.
What does Chris Cooley's stuff do? Does it parse header files, or does it make?
I think it's going the other direction.
No, it parses C code, and
that stuff.
Yeah, that's something else. Yeah, it does parse C code.
So is that known to work or not work for this purpose?
So I looked at it a while ago. So I looked at that, and I looked at Clang Link, because Clang Link also has stuff for parsing header files. I think Chris's stuff was a lot cleaner, but it cleaned up some of the information that I think you kind of needed in order to do this. Clang Link had more information, but it also had a bunch of other junk. But part of the problem is that there are issues like, okay, real libraries have tons of macros in their headers. right? So they
So
have
then you flow
if
it, then you flow
ndefs.
it.
So you essentially have to do compilation, with all the macros set and so on, in order to even know what the header files say before you can parse
And once
them.
the macros are expanded, it's a big pile of mess, which you can't read.
Sure. Right. So I mean, this is like one of 15 problems that make this
so
hard to
fine. But
understand.
let's talk about the actual realistic workflow, because it could be that's having a labor-saving device that saves 5 minutes of labor on something that necessarily takes 5 hours is pointless. So I mean,
right, it's much easier just to go to the documentation for OpenSSL and see what the signature is than have it trying. Right. Yeah.
But I mean, what is your workflow then? So you go to the documentation, you look at the signature, you're going to have to make up what the corresponding Wolfram language binding for that function is, for example.
Right. We can do an example. So this is one I've done before. I think there may even be an example below for this, but we can try and just do it so that we go through it. So this is a function in OpenSSL, rand bytes, that generates, cryptographically secure pseudo-random number generator, right? So if we want to call it, so here's its signature. So let's do it. So I happen to know OpenSSL is already loaded by default. So we're going to say create foreign function, rand bytes. Normally you'd call library load before this, but then we have an opaque raw pointer for the first argument. All pointers, arrays, whatever, are all just opaque raw pointers. If you want to have more typing, that's a layer above this, and it takes an int and it returns an int. And based on, sorry.
I just ask real quick because obviously, I mean, you pointed out that OpenSSL is already loaded by default, so it's not necessary to list it in that create foreign function call. What when you ultimately call DLSim, what value are you passing as the first argument?
I'm trying to remember. It's either you pass null or you pass, there's some like RTLD default, I think, which basically, so basically that first argument is not, DLSim takes 2 arguments, takes the name of the function, it takes quote unquote a handle to the library to sort of prioritize when loading it. But actually what I think it basically does is it searches everything in the process, and that handle only really tells it what to prioritize. So if there was a conflict, it will check that one first. So arguably create foreign function should have maybe at least an optional argument that lets you, I have internally, but it's not documented, I think it's called like create foreign function with library that uses that mechanism.
Yeah. I mean, that was what I was curious about, because like library function load, for example, the library link mechanism requires you to specify the name of the library. And that kind of makes sense, at least conceptually to me, because you could imagine it's not terribly hard to predict that some libraries will have symbols that have the same name. I mean, many libraries will have like an initialize function. Now, hopefully they prefix it with something that's kind of specific to that library. But I wonder if it shouldn't be the default that you specify the name of the library.
I hadn't noticed this point, but it seems right to me. I mean, why isn't it library name arrow that or
Right. So two things. The first thing is that library function load does something totally weird, because when you call library load, it doesn't just call DLOpen. It calls DLOpen, and then it puts the handle in some sort of central registry of all loaded libraries.
Is there a $loaded libraries?
I don't think so. I think there's like it's like in some weird internal kernel thing. It keeps track of what libraries you've loaded, and the handles, and it keeps track of the paths and the handles associated with them. Right. I think probably the better way to do it, sort of as mentioned earlier with calling library load, is have library load returns some library object that's basically the handle, and then when you call library function load or whatever else, you use that handle again. I think it'd probably break a lot of things to change that, though.
What would it? I understand. What would it break? Because if you don't specify it, you're saying that many.
Well, no, it breaks stuff because things assume that library load returns a path.
Well, maybe we didn't need a different name than library load.
Right. So I have a function here. I don't remember what it's called, but I have a function that's basically opens a library and creates this sort of library handle. It's basically exactly what we're saying. right. Oh, load external library. There it is. So if I say, let's see, load external library, and I think this is not really a consumerized function yet. So I need to say find library here, but obviously it could do that itself. And that produces this external library handle. And then I can do create foreign function with library, beautifully named, and I'll give it this as its first argument, like library function load, and it will use that to prioritize.
Okay. So yeah, so I mean, so one piece of this is the flow of, I mean, it seems like the obvious thing to do would be much like external evaluate with its session type stuff. There's either you have given a pre-digested blob as the specification of where what the library is, or you could perhaps give a string and it will, on demand, when you say create the foreign function, it will, load the library appropriately. Does that make sense?
Right. So you'd either, right. I mean, one version of that would just be there are two usages of this, one that takes 2 arguments and one that takes 3. If it was inside of external function, it would be that you either write quotes dynamic library as its first argument, or you first have a start external session of dynamic library, comma, a path. And that creates a quote unquote session, but the session is just one of these external library handles.
Sounds about right. I mean,
right, so you'd write. I mean, this is essentially how I think how kind of everything works in the external external evaluate. So you do something like this, that creates an external library handle, and then when you do external function, you can either you can write Python, or you can give it a Python session here. You can either give it this object, or you can just say dynamic library.
Yes, in which case it'll create that. But how does it know which library to create if you just say dynamic library there?
Oh, well, it does what this does. It just assumes it's already been linked.
Okay, fine. But you can also do a thing, I think, that the external functions, external evaluate stuff already does. We can say dynamic library arrow, blah, 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 to specify. There's some syntax for that. I forget exactly how it works. If you look up external evaluate, I think it has.
But that's
like that.
That's the return value, that arrow thing.
Oh, okay. Yeah, right. You're right. That's the wrong thing. That's for interpreted languages defining the return value.
But what's saying start
wouldn't that be in
session,
the second argument? If you do external evaluate. Oh, it is.
Yes, but his question is, where's the name of the dynamic library?
Yeah.
The point is, if you go ahead.
What's the advantage of start external session versus load library load, right? I mean, there's some global state, all the libraries loaded into the kernel, and why not just say library load? And then I strongly agree that it's useful to have a syntax in create foreign function that takes a library name or library specification of some kind and just do it all in one shot. But why call start external session here? It's really just another way to do. You might as well just call it library load if you can do it separately.
Right. Well, maybe I can look into. I mean, the basic reason, for the purpose of this being in a packlet, is that you need to get that library handle. And that's only available when you call library load. Like ultimately, when you load the function with DLSim, you don't need a path. You need this library handle. And the only reason that works with library load, the only reason why library load can get away with not returning the handle is because there's this secret internal registry mapping paths to handles. And I don't have access to that as a packlet.
Right.
But maybe that could be exposed.
Okay, so so we got a bucket of stuff to do with the specification of the library, and we still believe that it's worthwhile. Well, I mean, foreign function might be able to have an absolutely, do it on demand as opposed to create foreign function, which does a one-time DLSim or whatever it was called thing.
So you mean you'd have like a foreign, you'd have like a
the whole thing is there, the library specification, everything, and it's just and it just literally you just call it, and in a perfect world it would cache itself and things like this.
Yeah, that could be interesting. So you just write something like this instead of saying, ff equals create foreign function of blah 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 and then ff of this. You would instead just write this.
Or you can say
effectively
ff
write
equals foreign function of foo type. We just get rid of create foreign function.
right. It would just be this.
Right. And it evaluates, and then foreign function would evaluate to something that has a bit more, material in it. That would be
that could work. I mean, and the overhead for this is low enough that it's, I mean, as you saw, it's like 10 to the minus 6 or something.
Yeah.
So it's sort of like, the cost of calling a resource function is probably much higher.
Right. So Dan, our live stream, is asking, why not have create FFI of typed of the function name, comma, the signature? In other words, why have the type be separate rather than just saying typed of?
Right. Well, we had this discussion of it with library function declaration. I think the argument is that when you write typed, you want it to really be the case that the object in the first argument has this type, but here this object is a string. It's not like, at best, you'd want to write something like, in the compiler, you'd write something like this, right? To say that this thing has this type. Otherwise, it's just sort of dishonest because you're just saying this string has this type.
Right, makes sense. Because the foreign function has not yet made itself a thing that could have a type. The foreign function is this
is just a string.
All right, so let's assume it's, I mean, I kind of prefer the foreign function brand here to trying to stuff this into external function, but maybe that's not right.
Okay, well, maybe the thing to do is I should make this version of it where it's just using foreign function and where it sort of has this syntax like this, that's probably a bit closer to the syntax for external evaluating. We'll see what it's like.
Fair enough. But then there's a preamble there, which is very much like start external session, but it is the only, it could be even start dynamic library or load dynamic library or something. I mean, we can get out of the problem of the fact that library load, which is an old function, doesn't do quite the right thing. I think we can have an overlay of something different because this is going to be the modern version of this.
Okay. Yeah.
But let's see. Yeah, go ahead.
I mean, it may be the case that if you call foreign function directly, we can have it do the new behavior. Could library load, though? I noticed it seems like forever it's had a 1-argument form. Could it have a 2-argument form where the second argument is some kind of, a specification of what it should return, like a handle or a path, like just a string that's the type returns.
First thing arrow and then what it should return.
Or that, something along those lines.
Usually that might argument, though.
But, yeah, I mean but okay. That could be a magic string like path, library handle, maybe library name, who knows? And it could even be, I mean, if we wanted to extend this, in a world where, say, we can read dwarf debug information, it could be all, and you get an association of everything we can determine automatically about that library.
Yeah, that's a reasonable point.
Yeah, I think that sounds good.
All right, so let's go to talk about types and memory management, because I think
well, I was going to show this example with rand bytes because I think it'll make it clear what's sort of going on here. Right. So if I define this as a foreign function here, so this is where the memory management stuff comes in, though. So
that return is very bizarre. That return is incredibly type theoretic, so to speak.
This thing. Yeah. So that's another reason why it's good if it's wrapped up in some foreign function object that can have a proper box.
Yeah.
Right. But so basically, this is the place where it gets complicated, because so far, like with external evaluate has largely dodged this question, because basically the inputs and outputs of most interpreted languages are pretty analogous to what we have in Mathematica, and there aren't really many, right. But in this situation, we need to allocate a buffer, feed that into the first argument of this. It's going to write a bunch of bytes into it, and we have to read the result out. Right. So that means that we need to know how to allocate buffers, and we need to know how to read them back, and so on. And we have to be able to memory manage them, because I don't know, in this case, we maintain ownership of this buffer, but maybe OpenSSL is going to take ownership of it in some other case. And so the memory, we can't, the memory, there has to be a way of manually managing the memory.
Wait a minute,
Right.
wait. I lost something here. So wait a second. So you were about to demo rand bytes.
Yes. So rand bytes, if you read the documentation, generates num random bytes using cryptographically secured random number generator and stores them in buff, right?
Okay.
Buff is an unsigned char star. It's just the output of malloc, basically. Yep. So the point is, how do I get a buffer like that from Mathematica? I need to allocate a buffer, and then I need to be able to feed it in, read the result back.
Yep.
And worse, and this is why the memory management is complicated. You might say, well, you could automatically generate it when you call the function and so on, and then free it when you're done. But you don't know that because OpenSSL might take ownership of that buffer. So, right. So basically, the way to do it is I have a bunch of these functions, and I basically somewhat weirdly used the word buffer to sort of mean any of these sorts of time. Basically, any function that takes or returns a pointer, I call it a buffer, because it's just sort of some sequence of bytes. So we can try something like list to buffer. I have a numeric array one as well, but this will work here. So we'll give it some bytes, I don't know, or maybe we can say something more interesting like 2-character code of, and then we'll tell it the type. So in this case, it's an unsigned char star. So we'll say C unsigned char, actually, I think it might be, okay, I'm not sure what that is, but I think unsigned integer 8 should, oh no. Okay, let me try using the numerical array one, because I don't remember how this, or maybe I should just look at the example for list to buffer so I can do it properly.
Let me understand something in terms of the overall design of this packlet. I see a fair amount of complexity here. Is most of the complexity around this buffer memory management stuff, or is there some other pocket of complexity as well?
This is, I'd say, most of the design complexity is just around, making inputs and taking back outputs. Some of that's buffers, some of that's callbacks, which is another major feature. Stuff like that, though. That is where most of the complexity is.
Okay, let me just understand all the complexity, though. So, I mean, basically, it's how do you exchange data if it is being done in a piece of memory that is managed by the external library? Is that right?
It doesn't matter who's managing it. The point is just you have to deal with a bunch of C types, like C arrays and stuff like that.
But what if the thing is being passed to struct, for example? How do you specify that? So
I have a way of representing the types for structs. There's actually 2 ways. You can either, if say this, instead of it being a C int, it was some struct that contained a field that was first an int and then a float. You can, one way of writing that is with a list. So this represents a struct of an int and a float. The field names in structs don't exist once it's in a dynamic library, so I don't represent them here. They're just lists.
So then the call that you make, the sub-value call, will just be a list there.
Exactly.
That will populate the struct.
Right. Lists, structs get serialized to, from lists and to lists. So yeah.
Okay. So then the issue now is, how do you make a C array out of a list, for example? That's your list to buffer type thing.
Right. That's the list to buffer type thing. In this case, I'm going to use numeric array to buffer because list to buffer for some reason isn't working. But I mean, here it's similar.
In C, just so I'm understanding, in C, and is this true in all C ABI languages, that the that you can't pass on the stack an array? You only can pass a pointer to an array.
No, you can pass arrays as arguments, but actually, but they don't do it very much. They have to be a fixed size that's known at compile time.
Okay, that's what I thought. Right, you can't pass a dynamically changing. So I mean, a length 3 list, for example, you could pass on the stack.
Right, and in fact, actually, the way that libFFI doesn't natively support a way to do that, but what they say in their documentation, I haven't tried it, is that this is actually equivalent. An array of 5 ints is equivalent to a struct with 5 ints. And so really the thing you'd do is you'd I mean, maybe it can do this internally, but it's equivalent to this.
Right.
and it would come back as a list. So it all works out beautifully. So your arrays look like lists when they come out.
Right. Okay. I see. So then if it were to return that array or a struct, the return value from the function, from the foreign function called as a subvalue would be a list, and it's up to you to package that in an association, for example.
Yes. But again, that's only if it's passed by value. Most of the time, these things will pass arrays by reference. So it'll be something like this.
Okay. All right. So now let's take a look at this.
Right. So we have our rand bytes function. We have this buffer. I'm going to, assign it to a variable here. There are lots of functions for reading from this buffer. So for example, I could say buffer to numeric array, or maybe I could be dangerous and say buffer to list. Now I'll give it the buffer, I'll give it the type signature, and I'll give it the length.
Could I just ask, Christopher, because I think this is obvious, but I want to make sure. So when you do that numeric array to buffer operation, you get to specify the type of the buffer. Now I assume that this is it's not doing any side of casting of the numeric array values. You're not casting each value in the numeric array to an unsigned integer, and if it's bigger than an unsigned integer, it's getting truncated or something. You're just, it's like
it'll fail.
As if you.
So numeric arrays, right? So if it's just an unsigned integer 8, it'll just use the raw buffer. This is just using the compiler's mechanism for converting, interpreting a numeric array as a numeric array of a particular type. So if it's an unsigned integer 8 and I ask for it as an unsigned integer 8, I think it'll just copy the buffer inside the numeric array. If it's a different type, it'll attempt to cast it and it will fail if it doesn't fit.
So I don't understand. When you just return an opaque raw pointer, I mean, in C, you can do all kinds of stupid pointer gymnastics where you add 7 to go, deeper into the array and things like this. But why are we not returning there a packaged thing that says, I'm full of unsigned integer 8s?
Right. So why isn't there type information? The basic reason, two reasons. One reason is because that's nowhere encoded in libffi or in the way dynamic libraries work or anything like that. And the idea here is at least that the base level of this should not add any structure that's sort of not part of the way dynamic libraries work. So that it can so that you can do everything. And critically, because there are lots of weird cases where here's a library and it says it returns a number, but then you have to then interpret that number as a function pointer, 5 minutes later and pass it in somewhere else. And if it has a bunch of type information associated with it, it'll just either have to be ignored, in which case, why do you have it? Or it will be, or to get in the way.
The result of this is that list to buffer then has to have type information in it, because that thing there is very raw.
Which is the nature of the world, because it's like, right. If you get back an unsigned char star, or like you might get back a void star. What the heck can you do with a void star, right?
Right. Okay. And
so,
okay.
Right. But so this, now we're reading, there we go. So we wrote to a buffer and
can
we
I
read
write
from
to
it.
that opaque raw pointer?
Yes, there's a function named populate buffer.
Oh my
that I think lets you.
Does it have any idea how long that buffer is, or does it just let it go? Okay. Fine.
No, because C doesn't.
Great. It's really outrageous. I mean, in SMP, there were mechanisms that were very, primitive versions of things like this. And, then we were like, this is not a very good idea because you can crash your whole session by just making a small mistake. And,
indeed.
Okay. Well, I mean, the only thing that's good now is that the cost of starting processes is much lower and things like this. So, and there's much more infrastructure for maintaining, there are many more things which expect that processes die, I guess.
Maybe, yeah.
I mean, could we include the type information that numeric array to buffer result? And I mean, for example, if you use it in a context where you're doing an operation that in C would just cast away the type incompatibility. Like let's say you pass that, it might return typed of opaque raw pointer, comma, unsigned integer 8. And maybe there could even be a metadata field for the length. But then you passed it to something that has a different type. could it be, could we keep the type information as long as possible and then have functions that operate on it that behave in a C-like unsafe way, just ignore it if it's incompatible?
Right. So this is sort of the right. I think this is one way it could kind of work. So the main problem is just that either, right, as you say, either the C functions just ignore the type information, in which case it's a kind of marginal value. Its main purpose would just be if you made it in Mathematica, you can then interpret it in Mathematica, but that's not a very common case. More often it's you make in Mathematica and you feed it to C, and then you get back an output that's, won't be annotated as nicely, and then you have to read that back. The other thing is these functions will always have to at least have usages where, right, that could be an alternative usage, but these functions will always have to have usages like this that are fully explicit, because sometimes you do get back a void star and are told this is an array of this type of this length, and you need to have some way of interpreting it like that.
I guess the question would be, and this probably varies wildly just from C library to C library, how disciplined they are about types. If we went the approach of being somewhat strict, where it returns a type and there's no implicit throwing away of the type, like, so for example, if you pass that numeric array back to buffer to list and you had an incompatible type, it might return an error instead. And you say, you might have to include in your code some kind of explicit cast operation if you wanted to do that. Do we think that so many C libraries operate in a way where they're just doing those casts all over the place in their public API, that would be too onerous to require that?
Well, here's something that's like very similar to that, which I think will cause similar problems to the design. I'm not sure it's exactly the case you're talking about, but a very common situation is you have libraries with opaque objects. So for example, GEOS, like that GEOS intersection function I had before, where I said it takes 2 opaque raw pointers. Those are pointers to GEOS geometry objects, and GEOS geometry objects are some giant struct that's opaque, right? You're not gonna encode that struct here. And so the question is, what would you put? If you had an array of those objects, you could either do what happens in the compiler, which is that you declare there's a type. I'm going to call it GEOS geometry, and it's just going to fundamentally be an opaque pointer. But you can still do type checking to make sure that you're not confusing it with some other opaque pointer, or you just say they're all opaque pointers.
I think the fundamental point is you're going to have to understand a bunch of the stuff to use this. There's no point in packaging it any further, because it's, the packaging just isn't there. There's essentially no class of users who can just use the simple to use packaging and not have to understand what's going on underneath.
Right. It might still be useful to I think right. The other goal here was just that this, the main thing that's exposed here is like the minimal, this is basically just exposing what libffi has, right? In a minimal way, with no extra fluff. But I think it could make sense to add some fluff on top of it.
Okay, let me ask you a different question. That Refprop library, is that, does it become trivial to deal with that library through this interface?
I don't know the Refprop library. Was that the like reference materials or something?
That's the thing, thermodynamic data. It's a
yeah. I haven't looked at it, but it might be relatively, well, if it's in Fortran, I don't know if that complicates things. I've never linked to a Fortran library, but
I think it had a C-like, mechanism. That to me, it's like in the giant boatloads of libraries type theory, the impression is that there are lots of these libraries out there, but it will be nice to see some more examples, because otherwise it's hard to do the design if we don't have at least 5 or 10 examples. Right.
Well, there's some examples I've played. I've done something. I have some short examples, like one-off examples with OpenSSL. I have some more extended examples using like SQLite, and there was a couple other libraries I was playing with. But I've done real examples with this and with the compiler stuff and so on.
I think it would be useful to ask Roger and Rob and people like that about libraries that they are,
Well, yeah, actually, because I've spoken to Rob about this. So one of the big, and this is another sort of packaging of or maybe a thing that would be built on top of this. So several people I've spoken to, Rob and Piotr and things like that, have wanted to link to C++ libraries, which is much harder. And like in particular, there's one that they wanted, which was Apache Arrow. Right.
Why is that harder? Doesn't C++ have a C-like interface?
No, because C++ basically doesn't make libraries like that, or not immediately. You have to do compilation in order to. You have to do C++ compilation in order to call a C++ function. Because basically the problem is, if I have a C++ thing that has a templated function, you have to compile it for whichever template arguments you want, and that requires compilation. So the way the C++ libraries basically work is they generally are distributed mostly as header files. And then when you actually want to use them, you just include the header files. And then, when you compile it, it'll compile all those headers and so on.
So in the whole world of C++, there aren't dynamic libraries floating around.
Well, okay, two things. One, C++ can produce dynamic libraries. You have to basically tell it, you have to basically use this extern C mechanism and basically give it a type signature that's totally C proof. So no
you have to burn in. Forget the template. You have to burn in a specific type signature.
Right, and there can't be you can't extern C a class. Like it has to be functions and so on. But right, and so basically the way that this would work is just like with create foreign function. You basically give a representation of I have a function. This is its name. These are its arguments and its return types and so on. You'd have to say, I have a C++ class. This is its name. These are its template arguments. These are its constructors. These are its methods, et cetera, et cetera. And then from that, it would create this kind of object that then you could call and pass around, and it would automatically construct them and destruct them and so on. Now, the main hard part there, and of course, when you ask for when you declare it, it'll have to do C++ compilation to make a library that that then the foreign function interface library can link to. Right, I think that system would actually be very useful and very nice, but it's mostly complicated from a design perspective because you need to have some way. Here, if I want to tell you everything you need to know about a function in order to connect to it, all I need to tell you are the argument types and the return type. But there, it's like I need to tell you tons of stuff about templates and constructors and methods and whatever.
So it's going to be an association, basically. You have to pass in. Instead of, like, if you were using foreign function, you would then have to, instead of just giving a type signature with an arrow or something, you would be passing in an association of a bunch of stuff. Like,
well, I think it's going to be even more complicated. It's going to be some, it's going to be some, right, something like more like this. It's going to be kind of ugly because it gets really complicated, and there are a lot of different things you need to know.
And it's not simpler to use some kind of utility library that just provides a C wrapper around a C++ function.
Well, you mean that we can use someone else's library that does this wrapping?
Yeah.
So two things. One, you would still need to somehow specify what methods you want, what
sure.
with what templates and so on. So you still need to do a lot of this work. The second thing is those libraries, as far as I can tell, don't really exist. There's one thing I found called like CCP2C that kind of does this. But otherwise,
it's unbelievable. Decades go by and things are still very primitive. Anyway, never mind. Okay.
Yeah, I mean, as far as I can tell, right? Like when I looked at other languages. So first thing is that lots of languages have, basically every interpreted language I can find has some version of libffi built into it. So this is very typical to have something like this, but nothing I could find had a connection to C++. Like there's no Python library that I could find in my little bit of looking that was basically the, automatically connect to C++ in this style. Nor was there for Ruby or Julia or whatever.
Ethan on our live stream is asking, are there examples of braiding calls into more complicated C++ libraries like DLib or ML pack? What is a braiding? I don't know what a braiding.
I
is.
don't know what that means.
I have to look that up. Thank you for asking the question. We don't know. And Nolan's asking about commenting. CUDA is a good library to call out to, but CUDA is a whole different story, isn't it? I mean, CUDA Link, which is, a different strategy that we have to have. I mean, CUDA is not. What is CUDA? Is it a library is it a C-like library that can be called that interfaces to GPUs, or is it something of a completely different character?
I mean, I haven't used it much. First of all, I think CUDA is a language, but it's a language that you probably pass to some library. We pass, I think it's called NVCC, which is the CUDA compiler, which produces binaries that you can then use some kind of library to give those binaries to your GPU.
Right. Okay, but so the thing that we are targeting initially here is C-like interfaced libraries, and it will be really good to get an inventory of those and to check that those really, I mean, we know that there are some of those, plenty of those.
I mean, I've already made several of these sorts of, GEOS Link is one of them. SQLite's another. OpenSSL is another one that obviously could have been done this way. They're actually, I run into these quite often.
Yeah, Connor's pointing out that CUDA Link for Nolan on the live stream, we have a whole CUDA Link system that probably could do with some modernization. That's a whole giant thing for calling GPUs. Although there's an alternative path for doing that using our machine learning framework, and we still need to really understand what the correct future of all of that is. And really, we should be working with GPU companies on this, and everybody's like too busy and things are not happening type thing. But that's that's a different path. But let's come back to this.
Right.
Okay, so the basic thing we have to understand is all this buffer stuff.
Right. Well, let me finish this example quickly because I know it'll be clear a little bit more of the complexity also. Right. Okay. So we have the function, we allocate the buffer, and I should do this in a better way. So I'll just say,
you're spraying random pieces of memory out there.
Yes.
And you're forgetting what the pointers were, and so they're just floating out there on the heap.
Yes, but there's a solution to that in just a moment. Okay, so here's a buffer of 10 unsigned integer, unsigned integer 8s. If I do buffer to list of that, you see it's just a uninitialized memory, right? There might be something in it, or it might be zeros, or God only knows what's in it. This is essentially calling malloc.
And this is essentially doing peek, like old-fashioned in, what was it, BASIC? Yes, the function peek that just looks at raw memory.
Okay, well, yeah, I mean, the
peek and
also
poke.
What's that?
Sorry?
Todd knows what I'm talking about.
Peek and poke, sure.
Right, they look at raw memory.
Right. Okay. Well, this is peeking and poking, and there's a bunch of raw memory in it.
Funny.
So okay, if you want to use this though, then you'd say, call one function, and we'll give it the rand bytes, we'll give it the buffer, and we'll give it the length of the buffer as it asks for. If we run that, it returns an error code. I think 1 means it worked, but I don't know. But now if we try buffer to list, we'll see now it's been populated with a bunch of probably random bytes. And if I run it again, you can see we get new ones. So in order to make this a bit safer though, because right now we're writing to the same buffer a bunch of times, but we need to free this buffer. So the first thing is there's a function delete buffer that frees a buffer. Don't run this again because it'll crash your kernel, because I've already freed it now.
What happens if I then say buffer to list on that buffer? It'll still be able to do that, but
it depends. Right, you will now be reading from memory that it's technically been freed.
The same. Yeah, right. So what happens? Does it work?
I think there's a non-zero probability of crashing the kernel.
Why? Because of virtual memory mapping?
I think because OSs have all kinds of ways to try and make sure you don't read memory you're not supposed to, and depending on random chance, I think this might crash. Okay. So I'm not going to try it. So the way you should do this better is when you create the buffer, right? Because we know that this buffer, we're always going to maintain ownership of it. There's a function called create managed expression, and basically you give it. I mean, this summable is not specific to buffers. You can do it for anything. So if you have f comma echo, right? We now have this object, and if I say get managed expression of that, it'll return the f. But when this magic object, when its reference count goes to 0, it'll call echo of f. Like if I do, right, you see it called echo of f because this thing got freed. So basically, right, so if I do it like this, we're gonna have this buffer object, which is this opaque raw pointer, but it's gonna be wrapped up in this magic thing that should have a better box, but which will call the lead object on this whenever its reference count goes to 0. So now I can call this and I can, get the things out. I don't have to call delete buffer on it, and it will automatically be freed whenever it goes out of scope.
Presumably there's a one argument form of create managed expression, which has a delete, the appropriate delete as its second argument.
I should have said delete buffer. Well, maybe, yeah. I mean, the only, I guess it probably could. The only problem is just that it isn't, well, right, it's not always clear what the delete is. So for example, if you have an opaque raw pointer, maybe it's pointing to a GEOS geometry object.
Yeah, who knows?
In which case you need to call the free GEOS geometry function.
Fine, I retract my comment. I think it's not. I think it's hopeless.
Right. So this is the basic. This is a very typical flow. Is you create the function, and then the actual body, and we could package this as a gen bytes, right? Right. This is a very typical way you would do something like this. And,
right, and that will clean up after itself.
Right. Oops. Right.
Cool.
Also, just as a random note, just to sort of show off. So if I do it as a numeric array, that works too. And now if I try, I don't know, something like that.
That's fast.
Versus we have a I shouldn't but yeah, it's like consistently like an order of magnitude or something faster than random integer.
Nice.
But yeah, and that's a little that's cheating there. That's just OpenSSL is fast.
Yeah.
Okay. I mean, is this a criticism of random integer and that maybe we could make it faster, or is this just random integer by default perhaps uses a more secure mechanism than this rand bytes function? Like, is it legitimate that it's slower?
Yeah, right. I think that's a separate topic.
I mean, I think right. Random integer has all kinds of fancy things it does, but I have to imagine. I mean, random integer does not claim to be cryptographically secure, and rand bytes does. So I wouldn't say that
cryptographic security and statistical, randomness aren't necessarily that related, and blah 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 blah. Complicated story. We're about to run out of time here, and we clearly have much more to go through. I think we should schedule another one of these. I mean, mainly we're talking about the packaging of this memory management stuff. And I mean, scroll back up to the list of functions.
Down. Yeah.
Yeah.
Or I have a guide page. You can take advantage of
useful.
The magic of documentation.
Well, you probably could. Isn't it a loaded?
I have a. Yeah, I probably have a.
An actual page. don't you have click on your top right hand thing where you have your custom guide pages, which you didn't use, and nor do I yet. On the top right hand side of your documentation, front page
here.
Yeah.
Well, I don't really want to make a new one.
Yeah, that's kind of stupid, isn't it? We should make that. Okay, that's a thing for Aubrey. We should make sure that has the thing to say add existing guide page to that thing in the top right hand corner. I don't think we considered this case of Packlet once.
Got it.
Thanks.
Right. Well, we'll look at the this one for now then. Right. So this is basically the functions. Right. So we've got the basic stuff about creating and calling functions, a whole bunch of stuff for dealing with basically pointers, buffers, memory, then the managed expression thing, which I showed, and then callbacks, which are a whole other. I'll maybe show a very short example of callbacks. So here, this documentation example is not very good, but right here we have a library that has a function in it, and the function expects a function pointer.
Yep.
And it's a function pointer that takes along and returns along.
Yep.
And what it's going to do is it's going to make an array, and it's going to call this function on a bunch of numbers, and it's going to populate some array and return it. It's going to be leaking memory. So okay, so if we make that library and we load it, we can then create a link to that library, and we say that it takes an opaque raw pointer because function pointers are just pointers. Then there's this function create callback, which I'll first just show on its own. And basically, you just give it any expression here, and and a type signature, and it creates this callback object. Now, for reasons for reasons I can explain in a moment, you need to have manual memory management for these, because you don't know when it basically has to do allocation when you say create callback, and you don't know if the library you're calling is taking ownership of this callback. It needs to not be freed. So there needs to be manual memory management for this. But okay, so if I have this callback, right here I've memory managed it, but whatever, then we can feed that to this function, and you see it's going and it's evaluating this thing in the kernel. So it's actually it's calling this callback.
Very, very cool.
In the kernel. So you can do, I had lots of examples doing things like sow and reap, and all that stuff works.
So wait a minute. So basically the point is, this is a cheap way to get an external C program to call. I mean, this is the analog. Let me just understand. I mean, like, for example, the Python client library is a way to call into, although that's working through a completely different connectivity mechanism. This is a way that you could, in principle.
So this isn't an alternative mechanism for anything. This is just that sometimes, like suppose there was some C library you saw and it had a function called map, right? This isn't very common that you see that, but suppose you saw a function called map in the C library.
To which
map expects a function as an argument.
Right. And this is what you feed it as a function pointer, and that function pointer then becomes a callback. So the function pointer, it's the analog of an external function. Our external function, it is the C analog of an external function, so to speak.
Right. Another way to think about it is it lets C call the kernel.
Yes,
what this does.
No, I realize that. Right. Which is
and it is kind of an inverse, because basically what's happening is that whenever this thing gets called, it has to take a C long, convert it to an expression, evaluate it, and then convert the result of that back to a C long.
Right. That's very cool. All right, listen, we need to schedule a different time to continue with this. It's really nice, really nice. Is there anything else we need to cover right this second?
I don't think so. I think probably then the thing is I'll try and make some of these, package this up in a few of the ways we talked about, and maybe have a kind of a list of things to talk about next time.
Right. Let's schedule this soon. I mean, we're ready to, we could have gone on longer here, but this is it's very cool, even if it's sort of horrifying that it's interesting that the world of sort of this level of engineering has actually at some level, the things one needs to do, peaks and pokes and so on. I mean, peak and poke must be 50 years old, more than that. I don't know. Anyway, it's interesting. All right, I should run. Great. See you later. Thanks to folks on live stream as well.